Hello and welcome. I'm Eric Meyer. I'm a developer advocate at Igalia.
And I am Brian Cardell, also a developer advocate at Igalia. And on today's episode, we have two guests. Guests, do you want to introduce yourselves?
Sure. I'll go first. So I'm Dmitri Zagidulin. I'm a engineer and standards wrangler in general field of decentralized identity, access control, and storage. And I suppose decentralized social media.
And I'm Juan. I go by Bumblefudge Online. I consult widely, but I have been working for many years with a decentralized identity foundation, which incubates a lot of DID and VC product prototyping, design work. And I also work with the IPFS Foundation, which has been used in a lot of DID and VC prototyping over the years.
And for those of you unfamiliar with VCs, we're talking about verifiable credentials and not venture capital. The amount of time I have to mentally decode that in conversations is just.
Yeah, every time I looked at the calendar reminder for this, I was like, why are we talking to somebody about venture capitalists again? Oh, right, verified credentials.
Yeah.
And actually, I'm going to throw in a little interesting note. I actually laughed out loud a little bit when I saw who was invited. Dmitri and I knew each other socially like 10, 15 years ago. Dmitri used to live in the same town I live in, Cleveland. And actually, I believe has been to the house I'm sitting in right now.
Yes.
For bread and soup party and that sort of thing. But yeah, we used to hang out. We've played Rock Band together. But then Dmitri moved away and had other things going on and a whole career, and we hadn't really been in touch. And then all of a sudden, wait a minute. So hey, Dmitri.
Hey, it's really good to see you.
Yeah.
Yeah. So today's topic is a little bit different from what we talk about usually. I think it's a thing that we thought was a little bit timely because W3C had some press announcements and things. And I think a lot of people don't know what it is. And I'll say that for myself in W3C, I kind of watched from a distance thinking like, boy, I don't know, that seems really a little bit over my head. And maybe some of the people in the use case that are working on it are maybe things that put me off a little bit. And so anyway, it's had a long time to brew, and we're going to talk about verifiable credentials. So can somebody maybe give me a brief, who's got the best, 30-second to 1 minute pitch on what are verifiable credentials?
So verifiable credentials, think of them as a standardized envelope to make any kind of claims you want to stand behind, right? So specifically, for those techies in the room, it's a JSON object with a digital signature, with a couple of required fields for who's making the claim. Does the claim expire, or does it have any sort of time limitation? Who is it about? And everything else is generic. So picture a driver's license, like a US-style driver's license with the state that issued it, your name and some other claims, like whether you're fit to drive a car, what the limitations are, what your age is, all that stuff. And then the fancy security mechanisms at the bottom, like the holograph, there's digital signature in the barcode, that kind of stuff. Now, picture if the world got together and said, hey, this is a nice format. We're going to use this for any sort of claim anybody's making. But the idea is they are format to make official claims, either high value or low value. From high value, it's things up to, I don't know, access to a military base, plane tickets, whatever you can think of. First responder credentials, right? So for firefighters to get into the building, that sort of thing. To very low value of here is a raffle ticket, or here is a $5 off coupon for, your next box of whatever.
I would say verifiable credentials are a interoperability format to make a sort of generalized form of any user-controlled credential about them. So the most important part is so-and-so says this about me, and I choose who gets to see that self-contained export format. So I can cryptographically prove it. It's intended for offline use, intended for subjects to be able to carefully control where it gets shared. So in that sense, the most important part is the lack of phone home. Like anyone can verify this credentialized thing an issuer said about the subject. So it empowers the subject to choose which verifiers can verify it without needing any participation or leaking any intel to the issuer.
There's a whole lot here to talk about. One quick question that I had is you said that it was JSON. Does it have to be, or is that maybe one or the most popular?
Great question. The answer to that question, as many things in standards, was at least a 5-year fight, if not more. Long, drawn out fight. The current state of the art is it's usually JSON, but it also gets binary compressed and encoded into a couple of other things. But yeah, it's a structured document, most commonly JSON.
Okay, yeah, this is a structured document. That makes sense. And within this envelope, when we say envelope, it's hard for me to not think of soap. Do you remember soap?
Yeah, absolutely.
So when we have this envelope full of claims, but it's full of potentially independent claims, right? So
yes.
So you have this, like your state issues you a driver's license. That's the envelope, right? And inside that is a bunch of things.
Yep.
And then the example that I hear thrown about a lot that kind of it speaks to me a bit, right? Is like so I have a daughter who's of drinking age, and she goes to the alcohol store, the state store in Pennsylvania. We have state alcohol stores for hard liquor, and you have to show your ID, right? And maybe there's some creepy guy behind the counter, and she shows her ID, and it has like her address and stuff on it, and like, why does he get to see that, right? So what I've heard is that you can choose to share the fact that you're over 21, and that's it. So like that this basically the state issued a claim that you're over 21, and so they can verify those two things. Is that right? Or
That's right. So one of the tools in the verifiable credential toolbox is this idea of, if your state or your university or whoever gives you a bag of bundled claims, such as your age, your address, whether you can drive a car, your height, all that stuff, when presenting it down the line, you can select and unbundle it. So our jargon for it is selective disclosure, right? But that's just one of the tools in the toolbox. The other toolbox that we recommend is don't bundle them in the first place. There's no reason for the state to not give you a small credential that is just, you can drive a car, and then a separate one, you're over 21, and then a separate one, your height is over, I don't know, 6 foot or whatever, right? Now, there's practical and economical and biometric reason why these things are bundled. Partly so as not to issue multiple cards, partly because you need to bind it to your biometrics, which is a fancy way of there's your photo. So there are good economic and information security reasons to bundle those claims. But we like to remind people that you don't have to. You can issue these small standalone credentials in addition to being able to selectively disclose things like age and so on.
And I would mention also that I always emphasize it as a translation or as an export format, because it is not a protocol. It is not super opinionated about how you do cryptography. It's meant to be not just crypto agile, but almost like cryptographically neutral. So if your issuer is using a kind of cryptography that lets selective disclosure of parts of, redaction or subsetting or variously linkable forms of zero knowledge, that you get as fancy as you want with the crypto if issuers and verifiers are willing to use that crypto. It's a verifiable credential regardless of the exact, to drive home the paper envelope analogy, like the however that envelope is sealed, however it is stamped, however it is delivered, it's still a verifiable credential if it can be translated, right? Like if it translates to the same JSON, and if the subsets translate to the same JSON, right? So in that sense, there's some diversity of protocols used, there's some diversity of cryptography. Is selective disclosure has trade-offs, so there's like some people who want to use this kind, some people want to use that kind. It varies a bit, but they're all verifiable credentials because they all translate to the same sort of translation paradigm.
And just to be clear, when you say crypto in this context, you mean cryptography, not cryptocurrency. So we're not talking about VCs and cryptocurrency. We're talking about verifiable credentials
That's
and
right.
cryptography.
That's right.
Yeah, now that you mentioned it, there are on-chain VCs that use zero knowledge, but that's a pretty niche one. Most of the selective disclosure cryptography used here involves no nothing like that.
Yeah, I imagine that there is a use case for this technology to verify that you own cryptocurrency, but that's not the core thing here. It's just much like you could use this for plane tickets, you could also use it for cryptocurrency. For that matter, you could potentially use it for I own this bank account that has actual money in it.
Exactly.
Right.
Exactly.
There's a lot of use cases about, this person whose name you don't need to know does have a bank account with me, or like this identifier is this private key is held by someone who is a customer. Um, there are lots of payments use cases if you know a lot about the payments or credit card worlds. Visa and MasterCard are both doing a lot of pilots about this stuff. Sort of like in the credit card world, there's a lot of confidentiality. No party needs to know everything about you. Each party needs to know a different subset of your data, and lots of parties just need an attestation from another party. So when you really get into like fintech, there's tons of confidentiality, there's tons of expiring and revocable credentials of attestations for pseudonymous identifiers. The more you know about fintech, the more obvious of fit it is. So like they use it in one way, and in terms of the selective disclosure, I think the stuff that's going to get to market first is selective disclosure over OIDC. So it's like fancy JWTs. Like there is a form of verifiable credential that's just a JWT that you can redact parts of, and that's pretty neat. Yeah, Chris.
Wait a minute, we need expansions of those acronyms.
What did I say? JWT, a JSON Web Token. Oh, OIDC, OpenID Connect, which is the single sign-on system that most people use. Sign in with Facebook, sign in with your bank, sign in with your university credential. So so there is a 30-ish year old technology that is used a lot for partial attestation, partial trust. So like it somewhere where you only need a few claims from Facebook or Google or the controller of some sort of identity system. If you federate two identity systems, they trust each other's assertions. That's the phone home version, right? Like that's a little less portable. That's a little less subject managed. But they have a version of verifiable credentials that phones home less than older forms of OIDC, and that allows redacted credentials. That's probably the one that most people who work in the web professionally will hear about first and will be widely rolled out first. Microsoft and the intro system on LinkedIn uses this stuff. There's a lot of prior art you can play with, like toy implementations in the Decentralized Identity Foundation GitHub repos. If you just need the JSON Web Token, the sort of like older claim structure that federated identity uses, you just want to be able to share half of it with someone. That's sort of like the most familiar form of verifiable credential.
So I mentioned earlier that like I watched this play out from a distance. I don't know, maybe 2013 or 14, I think. I was at some meetings at W3C, and there was like a lot of excitement around cryptocurrency, really. And then there's like these arms out of that are like, what do you mean by that? What parts excite you? What and so there was a lot of people who were interested in blockchain and then the use cases of blockchain and things. So like What is the relationship inherently here to blockchains and cryptocurrency? Just like since Eric had mentioned something about that. Yeah.
That's a great question. So the cryptography is the relationship, to put it simply. Here's what I mean. In a lot of ways, the verifiable credential community builds on some of the investment and infrastructure that that Bitcoin and other cryptocurrency brought along. Specifically, verifiable credentials wouldn't be in as good of a state if billions of dollars weren't dumped into public and private key formats, signature formats, cryptography libraries, building cryptographic API into the browser itself. Now, a lot of that was also driven by things like Twitter and Google and single sign-on rather than cryptocurrency specifically. But we all use, at the baseline, we all use those libraries. So what do verifiable credentials and cryptocurrency have in common? They have in common public-private key cryptography, digital signatures, and the hardest thing in both cases is secure key management, right? It's storing your secrets. It's, oh no, I have this hard drive on it is, $1 billion in Bitcoin, but I forgot the password. Similarly, I could have a credential wallet. I could have a storage or a mobile app or something that has my passport, my birth certificate, and all this stuff. But if I forgot the password to it, if I forgot the keys that make it work, then it's inaccessible. Although, because it deals with governments and institutions and things like that, there's a lot more opportunities for recovery and reissuance, unlike cryptocurrency. So this is more of an institutional and social aspect of things rather than, I don't know, purely libertarian.
I'd push back on that a little because there's nothing inherent to cryptocurrency that makes the private keys harder to manage or unmanageable. It's just a different trust structure. And the cryptocurrency world has to squat semi-permissioned in the mobile browser, in the mobile operating system, in the Play Store. There's this very uneasy relationship between the Google Store and the iOS Store and applications that handle something that may or may not be currency, right? Crypto wallets can't exactly do what they do if they give 30% of every transaction to Apple. So in a way, the relationship, so reframing Dmitri's answer slightly, I would say there's no inherent relationship to blockchains, just as there's no inherent relationship to OIDC. But if you need this to roll out quickly, if you need this to be for mass market, if you need this to not be taxed 30% in the App Store, your options are either it's going in the Apple Wallet and Google Wallet, or it's going into a independent wallet that needs to be maintained by an organization the end user trusts a lot, like a university or their bank or their government, or it's in some wallet that they sideloaded because they already had to do cryptocurrency things, right? The trust model for a wallet's like a user agent you have to trust a lot. It's having a wallet that it lives in a browser extension, or a wallet that has to be sideloaded, or a wallet that is an app that can't pay 30%. Like, whether or not you are using a cryptocurrency wallet to sign, hold, and present VCs, or an Apple wallet, or a web-based OIDC wallet, are kind of the three most realistic ways to bootstrap a trust infrastructure that's already there.
Yeah, I was going to say, it seems like you say, blockchain is one way you could do this, but if, for example, Apple IDs could issue these verified credentials, like a lot of people and have set up Apple IDs so they can get access to the music store or Apple TV or whatever, they've already trusted that to some degree. They have an account that has access to things, right? Like I can have access to my Apple TV account, and then that same ID also has access to, if I paid for Apple Music, then like I have access to that. And, similarly for Google users, where they could become verified credential issuers.
That's exactly it. Yes.
Yeah. And, Amazon, a lot of people use Amazon and have given Amazon a lot of personally identifying information, including usually all of their credit card. And like you say, I live in Ohio. If the state of Ohio decided they wanted to issue these verified credentials or verifiable credentials, I could choose to use that. Or if I am of a particularly hard libertarian stance, I might completely reject that.
Exactly.
Yeah.
Exactly.
Can I ask a question about, like, all of this has to do with trust, right? Trust is tricky. It's difficult. And, like, a thing that trips me up a little bit is like, well, I don't know. Can you trust this thing? And why is this thing more trustable than that thing? And I don't know, forgive me. Let's get a little bit loopy here for a second, but like, I think about, well, today, most of this stuff has, some kind of, let's call it a paper receipt that they give me. It might be laminated and holographic or whatever, but like there's a physical object that somebody gives me. And when I go to the bar, historically, they just look at it and they say, I guess, sure, go.
Your birth year starts with 1-9, you can drink, it's fine.
Yeah, basically, right? Basically. And as a result, like maybe you also, found somebody to make you one of those before you had a legitimate thing. And it gets tricky because you have, Pennsylvania driver's license is different than Ohio driver's license, is different than a driver's license in the Czech Republic, is different than a driver's license in Mexico, right? And I think that one of the ideas of why you would want an interoperable verifiable credential like that is specifically because, if I'm on vacation in Spain or Italy, they would like to make sure that I actually am licensed somewhere to drive an automobile, right? And how do they do that, right?
Yeah.
So I think that one of the things that I understand really helped give this a necessary kick in the butt along the way was COVID. So do you want to maybe talk about that a little bit?
Yeah, I would love to. So you touched on all of the key aspects of it. What's easy about verifiable credentials? Well, creating structured documents and signing them. What's hard? Everything else, all of the structure, all of the trust infrastructure that you're talking about. How do you know the key that signed this belongs to the state of Ohio? How do you know, that particular state of Ohio bureau is authorized to issue driver's licenses in the first place, right? It's usually trust infrastructure and turtles all the way down. You touched on a really important aspect of standardization. And we see the full range of standardization via monopoly. It's standardized because it's Apple providing the infrastructure behind the scenes for all of it. And we've got standardization through, loose trade associations, and we got standardization through the UN, but more realistically through the European Union, right? European Union says this is what European driver's licenses look like. That means all the states there. And then some other countries are like, well, they decided on what it is. We're just going to follow theirs, even though we're not part of the European Union. So all of that comes into play.
Yeah, and like you say, it's trust and turtles all the way down, but that's real life. So
yeah, exactly.
It's here's my ID, and whoever's looking at it, if it doesn't immediately look fake, just sort of has to trust that you're giving them a real ID. And there are varying levels. At the bar is different than when I'm going through the security checkpoint at the airport,
Right.
where they look a lot more closely at whether or not my passport will actually like scan and get a verified response from wherever it is that they're pinging. And I guess the person running the machine, whether they realize it or not, is trusting that the ping they get back is coming from the place that they think the ping comes back from. So
exactly.
This does not necessarily solve any of that, but it doesn't make it worse.
We say that a lot, that at least it's strictly no worse than the current system, but in many cases better. So the subject of driver's licenses and age verification is near and dear to my heart. Before coming to work with Juan and coming to work for MIT, I worked for a company called Digital Bazaar, who has sort of pioneered a lot of these digital credential standards. And one of the hats that I wore was project coordinator for the True Age project, which is an age verification project in the U.S. That is run by the National Association of Convenience Stores, right? So standardization through a trade body. And as part of it, we had to convince a lot of cranky and busy and don't give a damn operators of convenience stores and grocery stores and gas stations, like, why are you bothering me with this? Well, because really excellent, usually Chinese made fake driver's licenses are coming and are here, and they're resulting in a whole lot of fraud and resulting in a whole lot more reliability for you. Here's an alternative mechanism that the government, stands behind that results in fairly significant lower levels of fraud. Here you go.
I'm glad that you mentioned the thing about standards there, because it being no worse than existing or whatever. It would be helpful maybe to talk about how standards work. When the W3C was formed, I read about it with great excitement. And I imagined that it was something like the Supreme Court or the School of Athens for the world technology, and that they would hand down a judgment, and then that is what the world shall do. But it's not like that at all, really. And
I wish it worked like that.
Well, I'm not sure that I do.
Yeah.
In practice, I think there would be good things about it for sure, but I'm also not sure how much worse it would be either. But I think that there's something good about the competition as well. But it does mean that you have this group, this trade association that is we want to develop this thing and we're going to use this. But there are other industry groups that are doing similar things that maybe aren't doing this. There are other companies that have a lot of tentacles into things that are doing similar things that aren't this.
Yeah.
And how do we navigate that? That's Juan. Do you?
I mean, I would say we use the driver's license example a lot. There are my former employer Spruce in California is working on verifiable credentials for DMV use cases. And if you think about it, verifiable credentials, I keep harping on this, that they're the more flexible translation standard, right? A different trade association got together and made something just for driver's licenses with all of the semantics and the variability hard coded, because they're a trade association. They already know what the driver's licenses look like in the Czech Republic. And they basically, the driver's license issuers association of the world worked on this other thing that is a little less translation oriented. It's a little more hierarchical in the sense that if you issue an MDL, you aren't issuing a verifiable credential, and an MDL is uh like it's really tailored to that use case. You can't vary it as much. You can't change the cryptography if the cryptography isn't pluggable, so it's sort of a little locked to certain issuance infrastructure. And for things that are really centralized, right? You don't want to empower the user too much, or maybe not you. The people who issue driver's licenses don't always want to optimize for user portability, service swappability. They don't want a completely open market, right? So really, foundational documents, passports, and driver's licenses do tend to prefer these X509 revocable photo. They don't always need the strong suits of verifiable credentials in every use case. And there's plenty of hybrid stuff. There's plenty of dual issuance stuff. There's plenty of derivative credentials possible in more flexible formats. But this comes back a little to your point about the dystopian idea of a standards association just laying down the law and technologists having the color within the lines. I've been at a local first conference all week, and Peter von Hartenberg from Ink and Switch was his sort of talk at the conference was about malleability, right? Like software that's flexible enough that users at various levels and developers at various levels can sort of like fudge things, can have some flexibility, right? Like not hard coding and having this like end to end pre-hardened everything sort of colored within the lines, semantics hard written. The malleability of verifiable credentials, I think, is its strong suit, right? Like there's sort of issuers can choose how flexible or how translatable they want their credentials to be. And that sort of is a useful way of looking at them. It's like they're optimized for translation, and they can work with existing systems. Any producer and consumer of data that are already using a given blockchain, semantic standard, Rails, can sort of make the verifiable credential for the two of them that then translates better to the outside world, to future Martian anthropologists, etc.
You mentioned in there semantics, and one of the questions I have on my list of things to ask you is like, if I'm making a claim, you have to inherently somehow understand the claim that I'm making. Like we have to agree on what it means to whatever that claim is. So this is again going to my, like which when you are in a group like W3C or IETF or whatever, there's like a bajillion efforts happening and you cannot possibly be involved in all of them. So even when they sound interesting, you find ways to sort of short circuit and say something like, well, that thing is about cryptography and I don't really know anything about cryptography, but those people really do and I trust them, so like let them do their work. Or like those people are really deeply into semantics and the semantic web and they're chasing that thing and maybe something will come out of it, but it's not for me. And so one of the things I noticed, a lot of people who were very into semantics and semantic web were also involved here. And I'm curious, like, is there a relationship, and like how do you agree on the semantics? I imagine it's pretty important if you have this generic claims idea. What is the claim that you're making? Because I can imagine like several universes where there's different kinds of solutions to this.
Well, I would say quickly like that there's like I said, like with MDL, the semantics are a little hard coded because it's really for one use case. For use cases where there's never going to be a universal dictionary, like educational credentials, there's always a patchwork of like, well, this European association said this, and the International Science Foundation said we have to agree just for the chemistry degrees, and like for places where it's always a sort of patchwork, mix and match, tentative thing, you need something where the semantics can be passed by reference, not by value. You have to sort of have versioning. You have to sort of like just embrace that chaos and be able to encode in the credential enough references and breadcrumbs that the Martian anthropologist will be able to find those semantics. So there's different styles, like I think there is a very JSON-LD version of this where if the sender and receiver both want to agree to use JSON-LD credentials, then it's kind of sorted because each property is already linked to a version, permanent semantic web document, ideally.
So agreed. So as a user and as a technologist, I come across a new tech. I always want to know what's easy and what's hard, and where's the drama, right? And y'all have sort of hit upon all the important bits of verifiable credential. What's hard? Well, managing secrets and keys is hard for regular people. Institutions mostly have it sorted. Running issuer registries is hard, right? Whole idea of digital signatures is that they're opaque in the sense that all you can machine verify is that this object was signed by this key ID. What that doesn't give you is who does the key ID belong to. And for that, you need the trust infrastructure. You need the issuer registries. So that's the second thing that's hard. Running the trust infrastructure, which really running the white pages and the yellow pages of the world for the old people out there. and mapping these opaque key IDs to KYC. And then the third thing that's hard is what Juan was talking about for developers and for verifiers, which is to agree on the vocabulary, agree on the semantics of this is how we do an age field, this is how we do a name field, this is how we do addresses, this is how we do diplomas and areas of studies and skill credentials and all that stuff. And that is super hard. And the answer is exactly what you would think. Governments, monopolies, trade associations, loose bands of open source folks, and industry verticals, right? So like Juan said, so driver's licenses, that's easy. Well, partly because we've got the European Union, we've got the US, and we've got monopolists, basically. Essentially, all driver's licenses in the US are handled by a single trade association, a single monopoly, and a single technologist that you all know and love is very closely tied to that company. So with driver's licenses specifically, there is sort of a battle for the soul of the world between mobile driver's license standard, incubated in ISO, which is incidentally, if you want to read the specification, it's going to cost you $100 to read it. It's open spec, but it costs you $100 to read it. So, right, there's a difference in culture between standards organizations. So we've got mobile driver's license over here, and we've got W3C verifiable credentials over here, which is free to read, though it's got other problems because in order to participate, you have to be either either a member and pay dues or be an invited expert. So there's always gatekeeping somewhere. I just prefer the gatekeeping on the free to read part. So again, so with driver's license, it's easy. Governments can just specify the semantics and go. Everything else, it's hard. So for education, there is, like Juan said, a patchwork of European Union has one schema. Actually, it has two schemas, two fiefdoms that are fighting between each other. But eventually, they'll sort it out and there'll be one. But we also have a standards task force that does a best practices directory of if you're going to do diplomas, this is what they can look like. If you're going to do student IDs, this is what they can look like. Right. And so that Japan has its own similar body. So it's a patchwork as always.
Okay. So I sense that this is an entire series of rabbit warrens, all of which have holes that go very, very deep. And we only have so much time. And one of the things that I actually really want to get to is I am a user of the web. How do I use this in the browser? Or how does this get brought into my, I guess, everyday experience? Because there is a lot of, like most of us, when we're on the web, we're doing things that require some degree of trust, whether it's getting onto a social network or it's buying something from an online retailer or putting holds on books at the library through their website or, watching Apple TV or whatever.
There's good news and bad news.
How does that?
The bad news is so far with great difficulty. Good news is it's getting better. At the moment, you have to rely on mobile apps, browser extensions, or some very early, what are those things called? Polyfills. Browser API polyfills that mimic the UI of what it's going to look like when Apple and Google and Microsoft get around to it. The user interface looks a lot like, if you're familiar with passkeys, and both their convenience and problems. If you're familiar with storing plane tickets and driver's licenses in your Google Wallet and your Apple Wallet, right? It's that kind of stuff. So the UI and the UX of it is still very early days. Let me give you a simple example. How do you tell to the user that this digital credential has verified, right? How do you just like with browser certificates? We've had the long history of how do you tell the user the SSL cert is valid? Well, you've got this little green icon over here, and the entire weight of technological civilization rests on that tiny little green icon, right? So it's like that. What's the UI look like? This is verified. Well, you got this green check. What does the green check look like? Oh, or rather, what does the green check mean? Well, some implementers are pioneering the fact that it's not really one green check. It's a checklist of warnings and errors and validations. Like, yes, we know who signed this. Yes, it hasn't expired. but maybe it's been revoked and you're offline and you haven't checked the revocation registry, right? So all that stuff still being worked out. But we've got some good prototypes to play with.
Sorry, sort of the answer, so that I understand, is either I need to have some kind of app that I've installed on my mobile device or a browser extension for the most part. Is if I wanted to start to get into
no,
this
there is a third option.
right now.
There is what's called web wallets that use things like similar tech to single sign-on and social sign-on that allow you to switch over to this different website, pick your credentials and present them over to this website. So yes, non-app, non-browser extension options are available.
Yeah.
Where would I find such a web wallet?
I have a great one to recommend. So I work with the Decentralized Identity Foundation, which has been open sourcing and getting people to collaborate and co-design things that'll be open sourced for years. One of our most active members lately is an organization called ArcBlock. They have a lot of experience with like blockchain SDKs and AWS and making things pretty turnkey, right? So their website, arcblock.io, their website is a great one to just click around for 5 minutes and see it all happening in browser. So because verifiable credentials are this really cross-platform, cross-form factor, it's more like a verifiable credentials is a set of guarantees. Like however you interact with it through whatever UX, it's like a certain level of truthiness, as they say in Elixir. It's like verifiable credentials are not for the browser. They're not for one specific subset of the web or one form factor. And in a way, what they're competing with is the operating system wallet. The wallet that comes pre-installed on your operating system is like a password manager you didn't choose. And if there isn't this cross-platform translation standard, no one can compete with the wallet that's already there, which websites can also pass through the DC API, right? So boarding passes, MDLs, and a lot of high-value credentials, people are just put it in your operating system, only trust the operating system, right? If you want to just play around with like a slick demo where all the parts are on GitHub and like all you have to know is TypeScript, check out our blog. It's a good one. It's a good sort of end-to-end showcase of ideas that this community's been percolating. And coming back to the browser part, so in terms of what lots of people have been using polyfills and or browser extensions for cryptocurrency wallets and password managers. Two clear examples of where we really need the web crypto API to be gaining features that ship to browsers a little faster. The more crypto people could just trust the browser to handle, the better. So a lot of people use more conservative cryptography than they might like just so that the green check mark can happen in any website rather than having to be in a website that runs some library they didn't choose. So that's a lot of the stuff that'll make it to production soonest rely on web crypto so that every consumer doesn't also have to have a polyfill. It doesn't also have to have these complicated, heavy dependencies, right? So the more crypto gets into web crypto, the lighter these packages and polyfills and trust models get. So that's one sort of light at the end of the tunnel. For a long time, it felt like the decentralized identity community, the VC community, was front running the browser a little. But now that there's a little more crypto primitives already dialed in, it's a neat makes these things more realistic for browser based things.
Maybe we could say, just on the off chance that some of our listeners don't know what web crypto is.
Yeah, web crypto is a set of signature and verification and encryption APIs built into the web browser itself. Right. So in the bad old days, before, let's say, 2016, if you wanted to do a digital signature on your website, you had to load the JavaScript that actually did the signature, soft code, and perform it there. Fortunately, browser vendors got together and more or less standardized a couple of key types and a couple of APIs that moved that into the platform itself, so that much like SSL certificate handling, individual app developers don't have to worry about that.
And so part of that is you say which cryptography algorithms
Exactly. Yeah.
Yeah,
And there's 3 or 4. There's not that many. But as usual, there's confusion. Yeah.
it's the basics, but it lets you say on a website, this here's the signature from this pub key. Display a green check mark if the browser can check the checksum at last mile verification, right? And without the website having to have its own JavaScript, blah blah blah. The browser itself can just check signatures in these 3 or 4 most common curve. You know, if it has these inputs, the browser just does it reliably, and it's just there's no reason for everyone to be re-implementing it and to be loading 100 versions of the same logic into everyone's site. So that's what I meant about last mile verification. Your verifiable credential can be presented or shown or whatever, and that green check mark or red check mark could be applied by last mile code that doesn't need to roll its own crypto. This helps a lot getting some of these things, particularly the lower value, further from the original issuer and consumer of a credential, right? Like a credential is more verifiable to third parties and Martian anthropologists if it's all just standard crypto, right? And it's makes it more portable. It makes it more, and we talk a lot at the IPFS Foundation, which, by the way, supported some of this work on Web Crypto API. We talk a lot about ambient verifiability. So if you're using common primitives that are just like built into the browser by default, that really gets you to a place where that particular credential signed with these super common curves is almost like verifiable even out of context. Like it's just sort of ambiently, it's as self-verifiable as any hash or checksum you can check.
You talked about IPFS work, and that's something that Igalia did, actually, or worked on. So, yeah, it's interesting how these things all come together. But
way earlier in the podcast, like very early, you had mentioned that these other solutions maybe don't work for offline use cases or something like that. I seem to recall. So, like, how does that work exactly? Like, what is somebody needs to be online, right, to verify this? Like, somebody needs to be the verifier needs to be online. Is it right?
Or have a lot in their cache, right? So it depends on the use case of the verifier. If you're a driver's license verifier in the US, you really need essentially either to cache either one key from the US or, more likely a separate key from each state. Then that's not that many, right? And they don't turn over that quickly. So there's a lot of cases where the caching is useful for offline.
Gotcha.
And it's also worth mentioning too that like verifiable credentials, most of the original use cases in the use cases doc that the W3C working group was working on were not always online. Offline wasn't the best distinction. It was almost like public private. So it's like even if it's online, you might present it over a secure channel, and it's sort of like privacy by obscurity, right? Like you only give the credential to a consumer that you're also signing over the envelope to prove control of the key that it was issued against or whatever. So they were often, that is the most subject empowering flow, is to say, I can prove this credential was issued against me. Here is a credential that's like through some secure or ephemeral channel, and so I can prove in a private context that needs no phone home, that leaves no public traces. Once you start publishing a verifiable credential online, then it sort of is like using a chainsaw to open an envelope. It has all these translation properties you don't really need for public data. Like once something's online, it's sort of already the good guys and the bad guys all got it within seconds. So there's a lot of VC use cases in finance and in trade where you're passing along credentials along like a supply chain, where everyone is verifying it. And also, ports aren't the best connected places. They might also need to do some offline private verification of these credentials. They need to check these signatures, even if they don't know what the pseudonyms represent, even if they're not publishing stuff, because supply chains have a lot of internal they have complicated privacy confidentiality requirements, if not privacy requirements. So that wormhole goes pretty deep, to say, or a rabbit hole. There's a lot of ways in which verifiable credentials are optimized for non-public channels.
Okay. So my last question or thing that made me think of, Eric and I were talking about this the other day, and I was talking about the most cited example that I hear is like the liquor store example, right? Where all you need to know is that that the state verifies that I'm 21 or over here, right? Or I guess probably just verifies my birthday. I don't know exactly how that works, because again, we get into these like weird semantics. Like, that sounds really good when I say it here, but maybe somewhere else the age is 18, maybe somewhere else it's 22. These are completely arbitrary lines that we draw in the sand, but that's not even the question. The question is, like, this sounds very good in theory, but one of the things that worries me a little bit, that I'm curious if there's been discussion about, and I mean, I'm sure there has, because it's unlikely that I found the critical flaw in something in the 10 minutes that I spent in it, right? But it seems to me likely that once you have information digitally in a way that sort of at the register they can request information, that they will just request too much information.
Great question.
And you will give it to them, because it is like when you buy a computer or a piece of software, or you get in your car now, or you turn on your TV, there's a license agreement that's 487 pages that says, hey, would you like to use this expensive piece of equipment that you just bought or not? That's your choice, basically.
I would say that the a lot of like civil liberty organizations, the ACLU and the EFF, have been watching hawk-like as digital identity systems get rolled out by government and or trade associations as powerful as governments. They're terrified of this show me your paper state where anyone can ask for everything, right? And I live in Germany. Germany is one of the strongest skeptical member states of the EU on digital identity, that has too much oversharing of data, right? Or leaks of data. So one of the ways you mitigate this is on the policy level, and just every state where the current government and current population cares enough to make it illegal to ask too much, or to hold someone liable for asking too much, or for being a creepy dude who writes down the address when they see the driver's license. If you get into like the Byron Tao world, where private sector is allowed to amass preposterous amounts of money for advertising purposes, and then get sold to hostile foreign governments for military purposes, it's like, so obviously you don't have to be like a privacy nerd or a international wars cybersecurity expert to know it's bad to have strong identification being overused. Like, if the person selling you beer knows your address, it's bad. If the person selling you beer knows some identifiers they could use to track you around the entire web or physical world and get buy your GPS coordinates on an open market, that's also pretty bad.
Worse.
It's maybe a little bit worse.
Yeah. I mean, to me, it's worse also because it's efficient. The efficiency is part of why it's worse, right? Like, if, it's true that the creepy dude behind the counter gets to see my daughter's address when she goes in there. But, unless he's got a photographic memory, or he's like, hold on, let me write this down, he's not mass surveilling everybody that comes in there. But, the companies, if that's available to them, there's no company that doesn't want that information, right? There's no company that doesn't want to know how to send you mail or want to know
Absolutely.
about your purchasing habits or
So yeah, so there's two mitigations, right? Like one, you can mitigate it in meat space. Like your government can go after the person selling the data they didn't have the legal right to have. And there's sort of like the tort strategy, like GDPR. Anyone can sue anyone for having too much or asking too much, not being able to justify how much they have. And that is, I don't think, and I don't, a lot of civil liberties organizations and the Decentralized Identity Foundation don't think that's enough, right? Like governments change from one day to the next. The government might stop protecting its subjects from such abuses. On the technical level, you get into some trade-offs. Like if you really want to have like double-blind systems, if you want to have ephemeral things, if you want to have unlinkability, if you want like provable ephemerality, that all gets pretty expensive in the engineering sense, right? So um, I think that those more expensive, slower to roll out, harder to engineer technical ways of making data exchange more auditable, provably ephemeral, etc., are worth doing for things like foundational identity. Like if you can open a mortgage with the information leaked from our transaction, maybe you should be using more complicated cryptography. um, that's sort of the current battle is like, can we convince people that something more sophisticated and less prone to these Byron Tao abuses that Byron Tao has been publishing about the secondary markets for? I think we should be exploring those as much as possible and making sure we don't pour cement around the simplest, fastest way of doing things and then never
So I
make
want to
progress.
yeah. Dmitri, we'll give you the last word on this,
sounds
and
good.
then
Yeah.
we'll
So
say goodbye.
unfortunately, verifiable credentials don't solve difficult power dynamics, difficult social dynamics, right? No matter how sophisticated your crypto, if the company that you're logging onto, if your funny video site requires enough claims to open a mortgage before they do anything for you, right? There's no crypto that'll save you. Even if it's all super isolatable, revocable, like the power is still often between like consumer and provider of the service and so on. So essentially, we have to use all of the tools at our disposal: government, trade association, peer pressure, blog posts, naming and shaming. Like Juan said, choosing the tech that at least gives you the option for data minimization, right? Those of us in specs and standards or writing open source software have to make sure that when writing the protocols themselves, we build in the data minimization at the base layer. For example, the age verification, the True Age project that I was mentioning said this credential is only going to have three things: a one-time use opaque random identifier, your picture, and not even your birthday, your age category. You're over X, and that's it. Right. So, yeah, unfortunately, no shortcuts and no easy answers. Power struggle still continues, but at least we have some of the tools to enable the conversation, to enable the power struggle.
Very cool. So, before we say goodbye, where can people find out more about this and about each of you?
Yeah. So, I mean, honestly, just search engine searches. Do a search for W3C verifiable credentials, and see if your eyes glaze over. Do a search for our names. What would you say?
I'm bubblefudge.com. That's pretty easy to remember. The Decentralized Identity Foundation is at identity.foundation. All the W3C groups you probably know how to find if you're listening to an Igalia podcast. I think foundational identity use cases. If you're a policy person, you should just the right search terms are digital identity, because the debate around this is always, when people say digital identity, they're really talking about these foundational documents, things you could open a mortgage with, not frequent flyer mile tickets.
If you want to talk to us, reach out to us on Fediverse, Mastodon, Blue Sky, and LinkedIn in that order of preference.
Yeah, exactly. Same.
All right, sounds good. Well, thank you very much for joining us and for
Answering all of our
taking us
questions.
down.
Yeah.
Answering all our questions and taking us down a bunch of rabbit holes.
Yes, lots of rabbit holes in Great talking to all of you. Wonderful questions. Thanks, and good to see you again,
Awesome.
Eric.
Thanks very much. We'll talk to you later.